guys, good day. Today we'll be doing the experiment entitled buckling behavior of bars. And as the name suggests, what we'll be doing, we'll be buckling a number of bars and check to see the force as well as the inflection taking place in the bars. Now in my hand today I have one of the bars that we're going to be buckling. And behind me we have the experiment instrument that we're going to put to buckle these bars. Now basically what we'll be doing, we'll be applying a force which will be right here, and we'll be applying force onto each bar, and we'll be checking the deflection that is taking place on each bar. Now the stress gauge that we have here is actually going to be in the center of each bar, so we can get the maximum deflection actually taking place. Now there's a two-part experiment that we'll be doing today. One will be buckling 3 bars looking similar to this, and secondly we'll be buckling what is known as an unknown bar to check to see if we can figure out what type of bar it is. So I will go through it step by step because it's a little, although the experiment is extremely easy to do, it's a little bit complicated in terms of the amount of things you have to get done before you understand what's going on, because you're not here with me today. So we will break for a minute and I will go through each bar that is needed. Okay guys, welcome back. Now what we have set up, this is the first part of our experiment that we're going to be doing today. These are bars that is made out of stainless steel. Couple things you need to get, as I said, that is important for you. Firstly, you realize that the bar has actually gone beveled into the center. This is what is known as a knife edge point. The bars that we're going to buckle today are what is known as knife edge. And this is how we're going to pin it into the equipment itself, into a wedge area. Now you see that we have 3 length of bars. Important information again. The first bar has the length 700 millimeters by 20 millimeters by 4 millimeters thick. All the bars are of the same thickness and width. The only difference you could realize here is its length. So this is 700 millimeters in length, 500 millimeters in length, 350 millimeters in length. Now we understand that if we buckle this bar, it should be much easier and take less load to buckle than this bar, which is basically half its length. So what do we see? Do we expect that this bar, if let's say this bar buckled, let's say around 100 newtons, do we expect this bar to have some sort of linear equation in terms of, is it twice the strength, is it 3 times the strength, is it 4 times the strength? This is what the experiment is actually going to see today. What exactly takes place in the bars if we cut the length as we go along. So if we have this at 700 and this at 250, we will automatically think it might take twice the amount of strength in order to buckle from 700 to 350. We will look for that today. Additionally, what I have in front of me here is our deflection gauge. Now, I know that we have gone through the deflection gauge already, but I'll just make sure that we understand it once again what we are doing. The deflection gauge actually has 2 parts, an outer ring with outer dimensions and an inner ring with inner dimensions. The outer ring is reading with a black needle and the inner one is being read by a red needle. Deflection is being read in millimeters, and we have here 0.01 mm. So that tells us 2 things. 1, the smallest unit that this gauge can read, and 2, that all our units are supposed to have at least 2 decimal places. Okay, so the outer needle is going to begin once we start. So the first point after 1 will be 0.01, 0.02, 0.03, 0.04, 0.05. At 10 will be at 0.1, at 20 will be at 0.2, and at 50 will be at 0.5, or basically half of a millimeter. So the black needle needs to go around 1 complete revolution in order to make 1 millimeter. When that happens, you realize that the red needle has moved 1 stroke exact. If I go around 2 times, you realize the red needle has moved 2 strokes. So in essence, what we are saying is that the red needle is going to read all our whole numbers, and our black needle is going to read our decimal places. So I'm going to set up now to do our experiment, and we will go to the second part of our experiment when we're finished. Okay guys, we have the machine set up to do our first test. But there are a couple things I want to ensure that we understand what's going on. Now we're going to apply a load onto our bar itself. When we apply a load, basically what's happening is that it's going to compress the bar. And it's going to try to release that pressure, so it's going to try to buckle. But what's going to happen, we won't be able to determine if it's going to be buckling on this area or this area. So how do we correct that? Now what I've done, I have set my deflection gauge in the middle itself, or between the center of the how much the gauge could actually rotate. So it could rotate approximately 20 millimeters. I have set it, my red needle, at 10 millimeters. So why do I do this? Now, the bar itself, we want this experimental as. Being that we want to come next year and do this experiment, and the year after that and so forth, as well as the previous generations have taken place. So, what we do is buckle this bar basically in its elastic range. The manufacturer has given us an elastic range that is ideal so that the bar don't deform or get damaged, and they have recommended around 6 millimeters. So what I'm saying is this: when I buckle this bar, it's going to take the deflection. It's either going to go into this direction, and we're going to buckle it for only 6 millimeters, so 10 plus 6 is 16, or you can buckle in this direction, giving us a negative reading, and move from 10 minus 6, which will give us 4 millimeters. So our end result will either be 16 millimeters or 4 millimeters. The gauge here, once we apply our load, is going to actually read the amount of load it takes to buckle. We're going to be reading this in increments of 50 millimeters. The equipment is going to start at exactly 100 newtons. So when we apply our first load, it's going to be 150, then 200, 350, 400, and so forth until we get our final buckling load. So just give me a minute, let me make sure everything is okay, and we will start our testing. Okay guys, I have my writing pad with me, and I have Mr. Elon joining us to help us to conduct the experiment. It's basically a two-man operation experiment, so he's here to apply the load while I read the deflection gauge. So we'll begin. We have it at 10 millimeters, as I've said before, and our force gauge is reading at 100 newtons. So let's go. So at 150, we have 9.72. $209.53, 250, 9.24, 300, 8.70, 350, 7.75, 400, 5.34, and it seems to be going quite a bit. So we look at this gauge to see when we reach 4 millimeters. Stop. You're going too much. All right. Go back. Go. Alright. 4 millimeters, we're having 4.405. Okay, so it's pretty simple and easy to deflect this bar. So we'll be loading up the next bar, break again, load up this other 500 millimeter bar, and conduct that experiment. Okay guys, we have just set up back our 500 millimeter bar. We have wedged it in the area once again, and we're going to start our experiment. So we have 100, we're going to go to 150. 150, 10.01, 10.02, 250, 10.03, 300, 10.05, 350, 10.06, 400, 10.08, 10.14, 10.20, we're going at 550 now, 10.23, 10.34. So as you see, we are at 600 right now, and we're now starting to climb, as well as the previous one ended at 405 newtons. So 650, 10.4, 700, 10.63, 750, 10.82, 800, 11.15, 850, 11.74, 900, 14.28, so we don't expect it to reach 950. So you're looking at this page now, so see where we reach 16 millimeters. And at 16 millimeters, our force is reading 910 newtons. Okay, so if you realize, as we have spoken before, we have discussed that if at 700 and we cut our bar into it, we should have expected to see an increase of, let's say, around twice the amount of strength needed to deflect the bar at the same deflection. But we realize now, just by breaking it down around 150 millimeters, we realize that we have gone past the amount, twice the force that we have. So basically that throws it out of the, what we have said before. So what we look at to see exactly what 350 millimeters look like. So I would not do a video of that part, but what I could do is provide information for you guys. Because the video is going on for quite a while now, we're going to stop now. I'm going to provide you the information and you will be able to conduct your report. Thanks. Okay guys, welcome back. We're going to be doing the second part of our experiment for Yola buckling rear bars. What we're going to be doing today is what is known as your unknown bars. So if the camera guy could come in a little closer, we'll look at some of the bars that we have. Now these bars here, you realize are different colors. And no, I didn't paint it. This is the actual metal that we have. So these bars have dimensions 650 millimeters by 25 millimeters by 6 millimeters in thickness. Now, as I said, we didn't paint these bars, so I brought this scale just to show that even though these bars are the same length and thickness, we realize that is different metals. So what we'll do, we just take a weight just to see how these bars are. You realize it's 748 or 749 grams. Our center bar is roughly around 791.3 grams. And our final bar, our silver looking bar, is around 243 grams. So as I said before, they're made out of different metals. What we're going to be doing, we're going to be selecting one of these bars and decide today to do a buckling experiment on it to see if we can determine by looking up. So we have to be doing some research on it to look up and see if we can determine what type of bar it is just by buckling it. So I've selected my gold bar. Gold is my favorite color. So we're going to set this into our equipment and run the same test again. So let's break and okay, let's begin. We're at 5.07. Alright, we're going to come straight to 4 millimeters now. So at 4 millimeters, we're having 11.20. Okay guys, so we're having this unknown bar giving us a strength of 1120 newtons. Now, if you're going to be doing research, you'll find a range in terms of where this unknown bar will fall in. And once you find that range, you can determine exactly what type of material this bar is made out of. So this is exactly this is what the experiment is about. It will allow you to be able to determine the type of bar that you have just by buckling it. So I'm gonna just pause on a while and get some critical information that you will need to write up a report for both experiments. So just give me a minute and we'll get that information for you. Okay guys, for initial experiment, when we did the 3 bars, we have some important information to give you. One being the modulus of elasticity. We have that around 210 newtons per millimeter. And we have a moment of inertia around 106.6 millimeters. For this bar, once again, and let's go through the dimension once again. We have 600 millimeters by 25 millimeters by 6 millimeters in thickness. This 9 edge once again, and I believe every other bit of information you will be able to solve for yourself. So I'd like to thank you and hope you have a good time writing up the report.